Model Parallelism and Distributed Systems with OS and SageMaker. Definition: the technique of dividing large language models (LLM) and retrieval augmented generation (RAG) models into smaller parts and distributing them across multiple nodes in a distributed system. Leveraging AWS, Amazon Web Services, and SageMaker for efficient computation and scalability. Key components: AWS Services, SageMaker, fully managed service for building, training, and deploying machine learning models at scale. Supporting distributed training, ECS/EKS. Elastic Container Service (ECS) or Elastic Kubernetes Service (EKS) for managing and orchestrating distributed computing across nodes. Lambda, serverless compute service for executing code in response to events, suitable for lightweight tasks in distributed environments. S3, object storage service for storing model data, artifacts, and other resources. API Gateway, managed service for creating, publishing, maintaining, and securing APIs, facilitating communication between distributed components. Model Parallelism Techniques. Tensor Parallelism, splitting model tensors weights and activations across multiple nodes in a distributed system for parallel computation. Pipeline Parallelism, dividing the model into stages, with each stage processed concurrently on different nodes, optimizing throughput. Data Parallelism, replicating the entire model on each node and distributing training data across nodes for parallel training. Hybrid Parallelism, combining tensor, pipeline, and data parallelism techniques to optimize resource utilization and performance in distributed systems. Benefits: scalability. AWS ECS/EKS enables seamless scaling of distributed computations across nodes, accommodating varying workloads. Performance: improves model training efficiency and reduces training time through parallel computation across distributed nodes. Flexibility: supports diverse model architectures and configurations, adapting to different distributed computing requirements. Resource efficiency: optimizes resource usage and reduces overhead in distributed systems with parallel computation. Techniques: cost effectiveness: reduces operational costs by utilizing AWS managed services for distributed computing and model training. Tools and technologies: AWS SageMaker SDK, Python SDK for interacting programmatically with SageMaker services, facilitating integration and automation in distributed model training. AWS ECS/EKS, orchestration services for managing distributed computing tasks and containerized environments in AWS. AWS CLI, command line interface tool for efficient management and configuration of AWS resources and services in distributed setups. CloudFormation, infrastructure as code IAC tool for provisioning and managing AWS resources, ensuring consistency in distributed deployments. TensorFlow PTorch, popular frameworks for implementing model parallelism techniques in distributed training and computation. Challenges: complex infrastructure setup, designing and configuring ECS/EKS clusters and SageMaker endpoints for optimal performance and scalability in distributed model parallelism. Synchronization and communication, managing data synchronization and communication overhead between distributed nodes in parallel computation. Debugging and optimization, establishing robust monitoring and debugging mechanisms for performance optimization and issue resolution in distributed model training. Security and compliance, implementing stringent security measures and ensuring regulatory compliance in distributed computing environments. Skill set requirements. Requiring expertise in distributed systems, parallel computing, and AWS services for effective implementation and management.